Okay, here we are. This is video number 3 on stoichiometry. Yeah? You all right with that, Mustafa? No? You're tired, aren't you? Yeah, you look tired. Yeah? You have a good weekend, though? Good weekend? You're paying for it as we speak, though. Instead of sleeping and getting good rest and eating properly over the weekend, you probably were so busy having fun that you forgot to take care of yourself. That's probably one of several definitions of a teenager. Excellent. Okay, but that's a good thing. That's a good thing. All right, so how many people fall into that category today? Living on the edge over the weekend, not taking care of yourself because you're having so much fun, and you are tired and feel like crap.
The studying count is fun.
You studied this weekend?
Yeah.
I am very impressed. Very impressed. I mean, it is the weekend of the Abu Dhabi Open. Did I say that right? Abu Dhabi Open?
Oh.
Yeah. No, I didn't see the Abu Dhabi Open. I think people around the world are much more interested than anybody in here, and we live in Abu Dhabi. However, the Abu Dhabi Open is not in Abu Dhabi, is it? It is where? Right down the road in Khalifa City A, where we are currently in school. It's in the same town that we are studying in. So we have something in common, stoichiometry and golf. There's a connection. Yeah? Excellent. Yes?
Abu Dhabi is an emirate. Khalifa City is an Abu Dhabi.
I'd like to argue that fact. Let me look that up. The city of Abu Dhabi, I don't think that Khalifa City A is in the city of Abu Dhabi, is it?
No.
Khalifa Abu Dhabi is an emirate. It's not
And
a city.
then there's different cities.
Yes, but there's a city and there's also the emirate. Yes, correct. Yes, correct. It is in the emirate of Abu Dhabi. Yes, I stand corrected. It is in the emirate of Abu Dhabi. Correct. Yes, you're right. Absolutely. Absolutely. I knew that. But thank you. Absolutely. Very good. But it is not in the city of Abu Dhabi. Excellent. But it is in the emirate of Abu Dhabi.
Hence the name.
Well, yes, but many of the Grand Slam, I don't even know if this is a Grand Slam, but many of the golfing tournaments are not necessarily named after a town. I mean, a province or a state or something. Oftentimes they're named after a city that they're in or a golf course, etc. So, whatever. Anyway, but yes, that's actually true. The Abu Dhabi Open is in the province or the emirate of Abu Dhabi, correct. But it is in the city of Khalifa City A, which is outside the city of Abu Dhabi. Okay, let's begin. That's actually probably more interesting than continuing with stoichiometry, wouldn't you say?
Yeah, it is.
Yeah, don't you think?
Just do that instead.
Yeah, exactly. Now, if we were talking about stoichiometry leading into a video of the Abu Dhabi Open, that would be boring, but that was actually kind of interesting. So that was an interesting little intro to stoichiometry. How to connect stoichiometry with something interesting. That's always a quest in chemistry. Okay. Anyway, stoichiometry is a study of constant ratios, inherent ratios within a chemical reaction, represented by a chemical formula equation, otherwise known as a stoichiometric equation. And let me make a stoichiometric equation up. Let's go completely crazy. Okay, let's go completely crazy. All right. So let's say we have sodium bicarbonate plus HCl, and that's going to make, this is going to be a crazy one. This is going to be crazy. That's going to make sodium chloride plus carbonic acid. Now, I'm not done yet writing this. Yes? I want to teach a little bit about chemistry when I do this, because this unit is on chapters 9, 10, 11, and 12, and there's all sorts of things. It's really the guts of chemistry, what we're going to be doing over the next 2 or 3 weeks. Okay? Well, I want to just talk a little bit about equation writing, so that when you actually have to do the unit, the chapter on equation writing, it will be a little bit easier for you. Yes? Okay. This is a double displacement reaction, or double replacement. It's called the same. It's both replacement or displacement. Both are used depending upon the textbook you're using. So it can be called a double displacement or a double replacement, and that means this, that I have sodium and carbonate, I have hydrogen and chlorine, right? I have sodium and chlorine, and I have hydrogen and carbonate. See what happens? If you look at these two things as two separate components, that's A and B, that's AB plus CD yields AD and CB. You see that? How they're kind of switching? Yes? Well, that's exactly what happens. Now, when you balance a double displacement reaction, if the polyatomic ions are intact, you can balance the polyatomic ion. Instead of balancing each atom 1, 1, 2, 2, like you did in biology, that would drive me crazy. I don't really balance equations like that. There are equations that you balance like that, but there are equations that there are some tricks to balancing, okay? And you're going to learn the easy way to balance, yes? So if I have 2 here and 2 here, that's going to go 2. And then I have 1 there and 2 there, I go there. And it's going to be balanced. Because I have 1 carbonate, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines, 2 sodiums, 2 sodiums. Does everybody see how that's balanced? Very quickly, isn't it? Yes?
This is the way, like, you write down each,
No, I don't do that. I don't do that. You mean you write down each atom here, and then each atom here, and you keep taking an accounting of each one?
It's basically what you did. You said.
Yeah, but it's... You do it a little bit more mentally.
Yeah.
And you got to get used to it. It's like playing fast golf. Do you ever play fast golf? Anybody ever play golf in here? Play fast golf? Do you ever do that? Like you go in twilight and you got to get the game done, you know? You have like 2 hours to shoot 18 holes. Boom, 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 boom. It actually helps your game a little bit. Anyway, this is fast balancing.
But this also, because you might get, you might trip over yourself in your head, and you might get mixed numbers up, and if you write it down, you just might.
Understood. And you know what? When we first start this, you may want to take your time and make sure that you don't make mistakes. I don't really teach it that way because I rely on the fact that you probably had this for biology and it becomes easier. Those of you who didn't have biology, I'll help you. Trust me, just ask me. It's not a problem. I'll go over this and over this and over this. But I don't want to get bogged down with spending 3 weeks on balancing equations. I don't teach it that way, okay? Very quickly, I teach it. Yes?
Well, you say that to get to that equation, you would say outer and inner, outer with outer and inner with inner?
Yes, correct. Yeah, kind of like factoring in math, I guess, now that you mention it. Yes, outer and inner, yeah. Foil, but only outer and inner, yeah. Are you all right with that? Are you?
Yeah.
Okay? Yeah. Yeah. The way they actually say it in one textbook, one author would say, this is A, this is B, this is C, D, and it goes like this. And this is going to be A, D, C, B. Easy?
Turn the C now.
What did I do?
You
Oh,
put it-
sorry.
Yeah.
Thank you.
You're welcome.
Yeah. Okay. Easy? It's called a double replacement. Some people say double displacement reaction. Okay? Now, also, let's look at this in terms of equation writing. This is a, listen carefully. Salt of a weak acid, salt of a weak acid. This is a strong acid. This is a salt of a strong acid. This is a weak acid. You get it?
Salt.
This is a weak acid. This is the salt of a strong acid.
Salt, like.
Salt, like
Salt.
shake salt, okay? Salt is more than just NaCl. We have all kinds of salts. Okay, you get that? This is a salt of a weak acid, okay? Yes? Yeah.
And a strong
Okay, so when you have the simple way, salt, acid yields a salt and an acid,
Yeah.
right? Now, the weak acid will break down. The weak acid will break down. In other words, I'm continuing the equation writing. Okay, we're taking a long time to do this. Hopefully we'll get through this. We may not, actually. So what happens is I take okay, this is an acid. An acid, weak acids, generally decompose into an acid anhydride. An acid anhydride is a non-metal oxide. What's the problem?
Isn't that a combustion?
No, this is not combustion.
It's when you put salt in an acid.
No. This equation here
So
is this equation here is the decomposition of an acid. Okay? Generally, when you talk about the decomposition of an acid, you talk about the decomposition of weak acids, weak-ish acids. Okay? Some are stronger than others, but by and large. You have an acid, yields an acid anhydride. What's an acid anhydride? Sulfur dioxide, sulfur trioxide, nitrogen oxides, all kinds of nitrogen oxides, carbon dioxide. These are acid anhydrides, right? You take the water out of the acid and you produce carbon dioxide and water. Acid anhydride is a non-metal oxide and water. Clear? Now you have to balance this. Now another trick is if oxygen is on the left and the right, and you have this 2, 1, 3, that actually balances, doesn't it?
Yeah.
So that's pretty easy. So we don't even have to worry about that.
It's already balanced.
It's what?
It's already balanced.
It's already balanced, exactly. It's already balanced. So carbonic acid, that's called carbonic acid, right? 8 becomes ic, carbonic, right? Carbonate becomes carbonic, and carbon dioxide and water. Clear? Easy?
This
Yes.
is when you leave an acid to sit, right? And
Well, yeah. There's a relationship, and there's a lot of biological implications of this, which we'll talk about later. Yes.
I didn't get, is HCl a strong acid?
HCl is a strong acid. Yes, very strong. Okay. All right. Now, what I can do now is I know that this reaction is not going to be like this. How do I know that?
it's not balanced.
No, that's
It
balanced.
is.
That's balanced. But I know that this reaction isn't going to be this way, and I'm going to show you why. I can take this and I just substitute in. And I'm going to put CO2 plus water. Okay? CO2 plus water. And I had one H2CO3 here, right? Correct?
Yeah.
So I need to put in just whatever that was in terms of CO2 and water. You can double check to see if that's balanced, and you'll find that it is.
Did you have to do that, or?
Yeah, you have to do that, and I'm going to tell you why. That this is a gas. This is a gas. And you write it like that. Gas is evolved. The evolution of this gas, will drive the reaction forward. It'll drive it. as this gas escapes, you are actually reducing the stress on the right side of the equation so more gas can be produced. If I didn't allow that stuff to escape and I let it build up in the system, it would probably slow down the reaction. Could slow down the reaction. But if that gas is allowed to escape, allowed to evolve, it's not going to go back into the reaction.
Oh, it's like when you open a soda can. Keep the carbon dioxide going out, there's more carbon dioxide.
It's not going to go back in.
Yeah.
Once you release it, once you convert this carbonate to carbon dioxide, it's gone. It's not going to reverse. The reverse of that reaction is very difficult. Very difficult. Yes? So as I release that gas, as that gas is evolved, it's going to push the reaction to completion vigorously. You understand? Has anybody ever put baking soda in vinegar? Vinegar's acetic acid. It's also a weak acid. Baking powder, baking soda. Baking soda is actually sodium bicarbonate. It's NaHCO3. Very similar. Very similar products. Instead of sodium chloride, you get sodium acetate. Very similar reaction though. Yes? Baking powder and vinegar. Baking soda and vinegar, same thing. Baking powder has a few other things in it. Any bakers in here? I think there are a few other ingredients in baking powder. Baking soda is just sodium bicarbonate.
Baking powder comes in powder and baking soda is like little pellets.
No. You can get baking powder as powder. Baking soda is powder. I mean, you put that in your refrigerator and it keeps the odors. No, it's not little pellets. I don't know. I've never seen it in little pellets. I buy baking soda all the time and it's powder.
They grind it up.
I guess, whatever. I mean, it's always in a powdery form. You can always find a block of it, I'm sure, somewhere, depending on how it's produced. Sure. Okay, so that's the equation. And before we quit, we'll do the next part 4 on, what's today? Sunday? On Tuesday. But let's just write the values in. I want to write the stoichiometric masses in. Okay, can we do that quickly, do you think? You guys get a calculator out, and I'll help you, and we'll do this quickly? Yes? Then we got to go, then you got to go. Okay, you ready? You ready? You ready? I'll be your periodic table. Okay, I need calculators. You ready? This is going to be, you ready? 23 plus 23 plus 12 plus 48. What does that equal?
Plus 12? Plus what?
23, 23, 12, 48. 23, 23, 12, 48.
106.
106. Okay, here we go. 135. 36. Times 2. 72, right?
272.
All right, we know that sodium chloride is 58. 58 times 2 is 116. We know right away, there's certain things you'll get to know very quickly. Carbon dioxide is, anybody? And water is, that's 1 mole of carbon dioxide, 1 mole of water. 2 moles of this, 2 moles. So it's going to be 1, 2, 2, 1, 1. That's the ratio. How they react. 1 mole, 2 moles, 2 moles, 1 mole, 1 mole. See? Yes? You okay with that? Now, what I'll do on Tuesday, right? Mars Day, right? Is I will give you a mass here. So what is the matching mass there? How much of this will you produce, and this will you produce? Clear? Okay? Shall we do that for homework? Just a informal, okay? Let's say this is going to be 212 grams. A, B, C, D. I want to know the masses of A, B, C, D. Okay? Go. Have a good third block.
The mass